Good morning, everyone, or afternoon, depending on what time zone everyone's in. So we're going to get started here. It's 10 o'clock my time, Mountain Time in Edmonton. So we're going to get going. Thanks for everyone popping on here. I see we got a few as part of the call now, but I'm assuming more are going to be jumping in. But since it's just a half hour, we'll get started. So again, my name is Kevin Grover. I lead the customer success team here at Looq, and today's webinar is going to be on high accuracy with the Looq. We've done a number of other ones in the past for different kind of workflows and different ways of working with data, but this one is going to be specifically around how we can get the highest quality accuracy out of the Looq platform, what to do, what not to do, and we'll go from there. So going to dive right into kind of some of the basic slides we had at the start here for the other ones. Just a quick platform overview for folks that don't know anything about our product. We are a handheld-based photogrammetric device, so we have our QCam, which is a handheld device itself. That allows us with, it's got 4 cameras on it, it's got survey-grade GPS in it, as well as some onboard processing that we do. Our processing solution is a cloud-based product called QAI. That's where we basically just create the georeference models, point clouds, ortho imagery, and do all the photogrammetric platform for processing. And the last one's QApp, which is our web application for basically disseminating data, sharing, viewing, visualizing the data from there. So those are the 3 products that we basically offer as part of our stack. I'll breeze through these as well. Just again, how it works. It's a handheld system. We do get PPK corrections from a base station, cores network, any network of your own. We do have an auto solution as well that will pull corrections from a global network. You basically walk around with the device and you collect your data as you're walking. Allows you to collect overhead power, topographic surveys, site surveys, infrastructure projects, really any sort of outdoor built environment is really where we focus our capture with. On the office side, we do offer a number of ways, and this we'll be talking about today. It's kind of more of the processing piece. So it allows you to ground control. We do PPK processing. We've got some tools for doing some basic line work extraction and point extraction from the data. And then we offer a number of exportable formats to allow you to bring it into things like Civil 3D, PLS CAD, that kind of thing to actually work with the data from there. So just really quick overview about a Looq, but I'm assuming from most of the people other than the call or existing customers, maybe some new they're interested. That's really what our platform's all about. But now we're going to kind of jump right into how we can get the highest accuracy data with the Looq product. So I redid my entire slide deck here yesterday just because I didn't like how the overview of it. So we're going to look at this one a little bit differently here today. So we're going to look through a bunch of different steps and stages of processing, and we're going to talk about different accuracy. So one of the biggest ones is because we do PPK processing, so it's post-processed kinematic processing. That's a mouthful for our GNSS data. So we do offer an auto base, which is basically a global network that we subscribe to that has a correction service basically in every country. We also offer local base processing, which really just means you have the ability to run your own local base or pull corrections from a paid service or a cores network, any sort of network that just allows you to get a RINEX file. So why would we choose one over the other? So really, I like this kind of diagram around it. If you want to run auto base, if you only care about more relative measurement accuracy of your data. So for our power customers, people that are just doing pole-to-pole measurements, maybe you're just doing some clearances, line heights, that kind of thing. That's really where the auto base works really well for it. It's simple. It does geospatially reference our data, but it might not be as accurate as some other solutions like running a local base. But all the relative accuracy of kind of measured point-to-point measurements within the data set are very high. As we get over to the local base option, this is really where, just like other traditional GNSS kind of processing, the better the base data that you've got, the better the login interview, the better the shorter the baselines. That really just allows us to get the highest level positional accuracy kind of for any GNSS processing. So we're really no different than Trimble, Leica, AMLID, really any of the handheld GNSS products in the market or survey products in the market. We do get the best data when you're running a local base. So if you're looking at more absolute positional accuracy, so 3D point measurements, mapping, surveying applications, or particularly if you're looking to aligning multiple captures together so they do fit together more precisely, that's really where we do want to recommend a local base. So that's kind of a nice little chart to kind of look between the two. Autobase does work well if you know that there's corrections in your area. So again, maybe there is a core station near your site. Autobase will work fine, but that's kind of one of the black box things we got with our process. You really don't have any control over which station gets used. So I will kind of show these in a little bit more detail here about the different options. So the Autobase one, like I said, it's prioritizing convenience over accuracy. It uses a global network, so we pull from core stations, UNAVCO, other free network services. Coverage does vary by region, so every country is slightly different. Rural areas are sparse, urban areas have the best coverage. It does automatically pick a base station, but the one challenge with it, though, is that if that base station is down for some reason, which we have zero control over, it might pull corrections from another station that's farther away. So in the red, kind of the disclaimer out of this is you don't have a dedicated base station. You might get long PPK baselines, and not all of the GNSS processing will result in like a fixed GNSS correction. So that really will limit us in how good the GPS processing is for the data, which can impact the processing on downstream. We don't need high quality data GNSS in all cases. If you have high overlap, we can live with a little bit of lower quality data. But if we don't have a ton of overlap, that's really where we're heavily reliant on the GNSS. So I'll do a bit of the buyer beware one. The local base station, just like I said, is exactly that. So this is where we want to prioritize accuracy over convenience. So specifically for this webinar, when we're concerned about accuracy, this is where we do recommend running a local base. It's going to be the best bang for your buck. So but this is where if you want to pull from a CORS network, there's a bunch of DOT sites that have base station data. We really only need is a 1-second RINEX file is what we recommend. So if you know that there's a free network, you can upload that and use that as your correction service. There's paid networks like SmartNet or Trimble Positioning. Topcon's got one. GeoDNet, there's a few other products in the market. Anyone that gets a RINEX file, you can basically pull from there. And again, it allows you the flexibility of pulling that and knowing what correction service it's coming from. The third option is the user base station. So if you've got your own equipment from Trimble, Leica, Emlet is one that we're looking at providing, working with more. It's just a nice low-cost GNSS receiver that just does a really good job of collecting static data for the corrections. That's really gives you full control over the data. So you pick what station, you know where it is, you can enter the coordinates for it, so you know the highest quality of everything, and it also gives us the highest probability of achieving a fixed GNSS solution. Because that all we need is a 1-second RINEX, and that's zipped, and that's part of the process, and then we get done. The only downside to this, of course, it allows you do require to set up your own GNSS hardware or pull it from a correction service. However, I don't think it adds a ton of time to your workflow, especially if you've got more of a dedicated unit. It's pretty quick to set up a static one, even if it's on a bipod. You can set it up on tripod, whatever you want, just has to sit static for your capture. So it really does add a little bit of a step to it, but the downstream results will be significantly better. So that's the first one we want to focus on. The next one is how you walk. And I look at this, how you walk matters. So we don't have it's not do or die if you do this, but at the same time, we've done a lot of testing around this and we get better data when you do it a certain way. So like in the top image, you see that this is just a power capture, kind of walking from pole to pole. We look at how we capture the pole was similar, but in between, you see we've walked more of a straight line in the top image. The bottom one, we've added this like kind of snaking pattern. So what we want to avoid is walking in just a straight line. The reason around that is that if we are walking in a straight line with the camera systems that we've got, if you're only heading in the same orientation, we get basically the same pictures that are visible in the cameras all of the time. So there's no change in the geometry as we're doing the photogrammetric processing. So if you add the S pattern swagger to your capture, it just allows you to kind of meander a little bit side to side. It does change the orientation of what is seen in each of the images, which improves our reconstruction algorithms. It also changes the actual distance that you may be to objects in the capture, which also helps change like the parallax and the angles of what we're capturing in the site. So the benefit of this is it just does improve our reconstruction algorithm. So the Looq swagger, whatever you want to call it, does contribute to better reconstruction. So we do recommend this, even if you're walking more of like a gridded pattern on your site. Add that little meander to your path as you're walking, gets a few more steps in, but it really does improve the accuracy of your reconstruction. I can't stress this one the most, and this is just a traditional photogrammetric experience. So over capture, don't under capture on a site. So this is where we really want to harp on the lawnmower pattern. We do want the back and forth capture of all of the data on the site. If it takes you an extra couple minutes to do the collection, just to get into little nooks and crannies, make sure you got that overlap. Now that we've extended our capture length that we can do for a single capture up to a 30-minute collection, it really does help that just get that little bit more of data. We want to avoid things like single passes in the data. So that will, single passes basically just will introduce some kind of distortion into the model. We do rely on heavy overlap, which is very common in really just any kind of scanning SLAM systems. You do want overlap to kind of get into nooks and crannies, get complete coverage of your site. But for us specifically, it does help us with the reconstruction when we get really, really tight overlap. So in this example you see here, this is one of the examples I like. This is a McElhaney capture of one of our customers. You see that we've actually got a really nice gridded pattern. It's quite organized on the site. They've added the S swagger into it, controls at the corners, and they've circled around the control. So you just do want to circle around objects you care about, but it does allow you to capture everything on site. So circle around buildings, walk along curb lines, all of these things are great, but over capture area. So we want to get as much overlap in all of the site as possible. I like this one. This is just a very common thing just with survey methodology in general. Just like doing a conventional ground survey, loop closures are your friend. What loop closures allows us to do is basically close out an adjustment for how we do our photogrammetric alignment. So loop closure basically just means you don't leave walking out one way and then leaving it hanging, that it's only kind of one path out. You want to close it off to yourself, walk back again, get the gridded patterns kind of in the area. So what this does is, again, it avoids the single passes that we're trying to do. It allows you to close off the ends of your survey. So the no loop closures basically, no loop closures equals, I should actually say, no loop closures means that our model can be distorted. So what we've done here is we safely crossed at an intersection to cross and capture to close the north side of the road to the south side. Same thing on the west end of the project. We crossed it in a safe location to close it there. We highly recommend doing this in all scenarios for when you care about achieving the highest accuracy. So back and forth, you can close to your start. There's all sorts of safe ways to do it. If this happens to be that you might have to extend your survey a little bit just to get that loop closure, we recommend doing that. Just it does allow you to get just a much better data set rather than leaving like open-ended traverses kind of in your data, which is a very common thing in more of a traditional survey, in a traditional survey sense. The other is just environmental features in general. And this is very common with, honestly, SLAM systems, photogrammetry, other things as well, is we work really, really well in environments with a lot of features. So like the image on the left, built environments, things with vertical features, whether it's even trees or fence lines, buildings, etc., it really doesn't matter. It's just if there's texture, things look different, it's well lit, the environment looks like this, that's really where we get the best quality data. The right image, of course, we're going to be challenged in environments like this. There's limited features, there's high vegetation. All we can basically see is grass that's basically flat. You might see a little bit of ground in the background. We see a little bit of vertical features like some power poles, power lines, but those are much harder to reconstruct and the accuracy won't be as high. That's kind of where we do rely on the different algorithms in the different scenarios. So in the left scenario, it's really where our photogrammetric algorithms will be really tight and we'll leverage like the high overlap and generate a really, really dense data set that's very precise just for the photogrammetry. And the right one is where our GNSS basically takes over more. We rely on it more heavily in environments like that. But between the two, the vertical features, high textured environments will definitely yield the best data. So just keep that in mind. If we're doing areas that have limited features, increase your overlap, ensure that you've got high quality GNSS with the most that you can in the entire capture. That's really the only ways that we'll be able to generate a better data set when you've got some more sparse features like in the right image. So it's tough because every site is very different, but vertical features and high textures, we really, really do a great job with, and that's just where photogrammetry shines. The next ones, of course, as we get into things like ground control points. So ground control allows us to do several things. We don't need it for a project, but if you're caring about the absolute accuracy of a data set is where it absolutely does matter. So placement of where you put ground control points do matter. So what we're doing as part of our adjust to control process, which is all done in post-processing, is we do a minimum 3-point rigid body transformation or an affine transformation for doing the adjustment. So we're basically, like the image shows, you survey, you pick the 4 points, we best fit a plane to the data. We need a minimum of 3 points to define a plane, and we basically will fit the data using those points that are picked. So with this, it does matter where you want them. We want the ground control more at the extent of your capture. And the reason for that is then we're not projecting error outwards of their data. We're basically just inward, kind of dealing with all of our data inside of our capture itself. So have the points on the extent of the data. Make sure you have good capture out to the extent of where your ground control are. The GCPs just have to be visible in the point cloud during the post-processing. So meaning if you just kind of walk by it and it's a very small point, you may or may not see it in post-processing. So that's why slow down, circle around your control points, make sure that they're captured within the data, and that'll allow you to easily pick it out of the data afterwards. Yeah, GCPs at the extent, the one thing I do need to stress is avoid putting 3 points on a line. So when we're doing, like, you look at this picture I've got here, there's 5 points total, but I'm using 4 on the adjustment. It basically creates a very nice rectangle. What we want to avoid is a very narrow rectangle. So if we had only used 3 points kind of in a straight line, it defines a very narrow plane. The problem with that is then you have a lot of roll error because you're basically just only picking your points along the plane. So if you introduce that roll into it, it's really going to have a lot of distortion, a lot of errors the further you get away from the data. So that's why for like linear projects, it's basically meant to have 2 points at the top end, 2 points at the bottom. We like to say, or I like to have at least 4 to 5 points per capture, just for a bit of redundancy. What that allows us to do is we best fit a plane. It allows you to kind of determine how accurate the align to control workflow is done. And that is really what we're recommending for doing the 4 to 5 GCPs per capture area. We did just introduce, as part of our ATC workflow, the ability to have check shots. So these are in addition to the 4 or 5 points. So you can have other points. Like in this case, I picked 4 points. I have 1 point in the middle of my data. I could add that as a check shot. What it does is it completely independently validates my adjustment. So it's not used in the adjustment. It is adjusted based off of it, and then I can do my error checking to it. But big thing, placement of this does matter. So take your time ahead of time at the start of a project to figure out where you want to put these, how you're going to capture them, making sure that you're fitting them to best define a plane to cover your entire collection area. This is one that I also can't stress enough, is how did you survey your GCPs? On our end, you know what, we just have the expectation, our data in the end, we're kind of expecting more like RTK quality data. So when I say that, is basically the majority of the survey points that are done for GCPs currently are just using RTK quality data. So it will give us 2 to 3 centimeter accurate data, you know, kind of plus or minus an inch accurate data, because we can't be any better than that with RTK. You will get better than at times, other times you won't. It will have some variation in it. If you do a static survey to your control, of course, you can get achieve kind of 1 to 2 centimeter accurate. If you do a conventional survey or precise levels, yeah, you can get down to sub-centimeter, you know, half-inch, quarter-inch accurate data. The better your control, the better our data can really be in the end. We are just fitting to your data anyway. So if you did a site with like a ton of overlap and we generate this really tight, precise data set. If you were to fit that to conventional survey control with precise levels, that's all good to 5 mils. That's really where our data can kind of be on that accuracy of 5 mils to a centimeter, just because you're fitting to really good data. But if you put in poor GCPs, if you're surveying points under trees, surveying them around buildings, and we're basically fitting to something that has error to it, we're just introducing that error into our data. So focus on the quality of your GCPs, because that does make a difference with the data downstream. Higher quality survey means a higher quality data set in the end. So just a few things to avoid before I kind of jump into just a little bit of a case study of what an accuracy thing that we've got here. Things to avoid when you care about high accuracy. Avoid single passes. So avoid just walking in one direction. Even two directions in a narrow path, really, we're still getting some distortion in that data. We want to avoid doing that. You want to get better capture, add more S-turns into it, get more overlap. So narrow areas are also tough. So like this picture here, avoid getting right up near buildings, away from environments, away from trees. You want to kind of keep everything at least a meter away from where you are, just because it is harder for us to reconstruct on those areas. Avoid having yourself in the scan. People walking around is fine, but don't have the camera pointed to the side and you're constantly visible in it. Or if you're collecting from a vehicle, which some people do slow vehicle capture and they're holding it out of window, the problem with that is, of course, you're seeing the visibility of the vehicle in it. So we want to avoid having things in the scan that are kind of moving along with the QCam. Avoid heavy vegetation. Of course, the more vegetation, the harder it is to reconstruct. So keep that in mind. If you care about sites with heavy vegetation, it's going to be a little bit more problematic with us, or really any SLAM technology. They're harder to reconstruct in heavy vegetation, and their quality is not going to be quite as high. The last one, avoid featureless environments. So if you happen to be doing, say, like a rural road, that's just a paved roadway with ditches and there's absolutely nothing along the roadway. Honestly, that's kind of where I look at the intent of what we're trying to do. If you're really surveying that for the point of, picking off some break lines or feature lines for doing like a topographic survey, it might be better off just conventionally surveying it or using GPS. We will struggle in featureless environments. As much as we can do on our side, we're constantly improving our algorithms, but in those cases, we do rely on areas that have a lot of detail, a lot of built places, and that just gives us the best data we can achieve kind of on our end. Those are kind of some things to avoid, just some basic tips and tricks. So really we focus on quality capture, prioritize GNSS when we can. If you don't have good GPS for some reason, like in and around building things, honestly slow down, get a bit more overlap, get more capture. That will improve our reconstruction. So we do use a combination of all the different sensors. So just keep that in mind. If everything's working well with high quality GNSS, good overlap, good capture, good control, that will yield the best data set that we can achieve in the end. So kind of do just one really quick accuracy case study with a data set. This is actually from one of our partners, again, from McElhaney. So just to kind of show you what is possible with a really good capture. This is just a commercial site survey that was done in Calgary, just south of where I am. It was about a 2-acre site. Honestly, parking lot, building, a lot of features that would take a long time to conventionally survey. They needed to know every lane striping, every curb, all the buildings, all the infrastructure. There's a lot of features on this site. So what happens with this? It was a 19-minute capture to do this entire area of 2 acres. So with it, they made sure they did the S pattern. You look at the overlap that they did. They have some really good collection around the entire site. They've done a really good lawnmower capture. They've added the S pattern into it. They circled around the ground control to basically make sure that they're really finite and they'll stand out from the control. They did a really great site coverage, basically just for the collection. And they pushed that initially the 20-minute capture just to make sure they got as much as they could in the 20 minutes. Now we can do up to 30 comfortably with our latest release that's coming out. So we can push that up a little bit more. So it allows you to do a little bit of a bigger area. They did run a local GNSS base station on this site. And they did put GCPs at the extents and their RTK quality control at the extents. But we do have some new metrics now. So this is actually one of the graphs that we've got now in our PPK report. So in looking at the GNSS processing of this, we had a 57%, might be hard to read, 57% PPK fixed certified. That's our highest quality PPK fix that we could get. So we weight that really, really high. And that's basically all the dark green. The light green is a PPK fix solution, so it's still a good solution. It's just not quite as good as the certified. So this site, we had some really good coverage, but we had about 5 to, I'd say 7% of the data that wasn't good GNSS, kind of in the red and the yellow. So that's going to be when we're in and around buildings, trees, etc. But with good capture and decent GPS over the majority of the site, that will give us a really, really good data product. So with this one specifically, this is the data we're achieving out of the end. So we can see from a survey methodology, from a site survey perspective, we're getting more than enough data that we need to extract curb and gutter. Maybe it's an ALTA survey, a site survey, an architectural survey that we're looking at doing. We can get buildings, features, curb lines, paint lines, all the utility data. All of it does stand out really, really well. So in the GCP workflow we had on the side, this is where we're able to, on this site specifically, able to achieve a 3D RMSE error of 13 millimeters. So half an inch overall error just by doing good capture with RTK control. Total time on site for this was 20 minutes for the capture, probably about 5 to 10 minutes to set up at the base station, another probably 10 minutes to do the control. So really in under an hour, you're in and out of this entire site with all the survey control needed, and we're able to achieve 13 millimeter accuracy data, which is completely a function of the quality of the capture that was done and the quality of the control that was placed. So really good scenario. We're able to achieve this on sites like this with good quality GPS and good coverage. We've got a little bit longer than normal. We got about 4 minutes left, so we'll just kind of a couple housekeeping, keeping things at the end here. But thanks for joining here, and I'll turn this over to Teresa to talk about a couple of announcements we've got here.
Thanks, Kevin. So a couple of things that I wanted to talk about, which is our next webinar that's coming up on January 20th, working with Looq Data and AutoCAD Civil 3D. So I'm putting in the chat right now the link to go ahead and register for that if you're interested. So you don't even have to think about it again. Just go ahead and get yourself registered. The other thing, I'm excited to let you know that our user conference registration went live this morning. So we'd love for you to go to looq.ai/user-conference. You should be able to find the user conference if you just go to our main webpage. Check out what we're planning to do. We did add a little bit more to the website. If you have been out there before, we've put a little bit of the agenda out there and the ability to now go and register. So we definitely hope that you plan to join us in May, and now's the time to go get that approval from your managers to go. So we look forward to seeing you there. If you have any questions about the user conference, I'm always happy to answer any questions that you have. If you're in the registration process, if you email us through that process, I will get it and I will answer your questions. Thanks, Kevin.
Awesome. Thanks so much, Teresa. So we've got time for some questions, or I'm happy to stay on a little bit longer if we need. So feel free to put them in the chat or the Q&A. But I do see that Carlos actually put in the first question here is, when is the 30-minute scan available? So we will be doing an actual firmware update very soon. We're actually testing it with a few customers right now. We've got a few things that were part of that firmware update. So it's going to be changing the warm-up process as well as kind of the warnings you get within the application. But as of right now, you can still technically do a 30-minute capture if you just ignore the warnings during the collection. Currently, we warn you at 15 minutes that you're coming up to the 15-minute threshold or 20-minute threshold. At 20, we say you've hit the threshold, but you can feel free to collect longer than that. So ignore the warnings short term, and you can do up to a 30-minute capture even now. Make sure you've got that overlap. Make sure you have a really tight capture, and then you'll be able to successfully do up to a 30-minute at least collection. And we're going to be working on extending that up to an hour, 2 hours, kind of the next few months as well. So just going to come with a little bit more coming up. Anyone else has a question? Put them in there. Oh, no worries, Carlos. I guess, Teresa, do you want to take any people off mute for it as well if they want to come off? If you have a question, you can feel free to raise your hand. If you want to be brave and ask a question, we can take you off mute for that as well if you're interested, or just put it in the chat.
Yeah, feel free to raise your hand and I'll unmute you.
Awesome. Carlos raised his hand again.
Should be good, Carlos. If you're not, let me try again. You have a microphone.
Put his hand
maybe,
up, maybe not. So
if you want to type it in there, please do in the chat. I'm trying to unmute you, but it doesn't seem to be working. Sorry.
I think it worked. Yeah, it was taking a minute. Can you hear me?
I can. Carlos, how are you?
Hey, pretty good. How are yourself?
Good, thanks.
Yes. So I have a question. So let's
Yeah.
say I set up my control points. And for some reason, now that the scan is a little longer, I go past my control points. Would that affect my scan?
Yeah. So yeah, and I think this is kind of probably tied to a collection you did the other day. So definitely, we do want to. You want to pre-plan your ground control ahead of time. So you want to make sure you do have your points down, at least know what points you're going to be using ahead of time. So when you do the collection, you're trying to collect to the extent of where you have control. If you happen to go a little bit further, again, this is where we still have the benefit of you can add control points after the fact. Sure, it might not be a target that you have placed in the scan, but maybe it's a visible feature. Maybe it's a expansion joint in the concrete. Maybe it is some other visible target on a the nut on a fire hydrant or something like that. Like there's other natural control points that you could technically use. So if you wanted to go back and survey it in afterwards, and then you could add it to your GCP processing. The thing that we just want to avoid, like I said, is just you want to avoid that if you've got a bunch of usable scan data outside of where your control is, it's just kind of buyer beware. Because we are doing a rigid adjustment and we're basically adjusting to fit the plane. If you've got data outside of where your control is, we're just projecting potential error if there's any error that exists in the alignment. So like I said, 3 points in a line, that's the worst scenario because then it just projects error out. So try to avoid it. Try to have your control at the extent of your site, but you can always add in points afterwards. So
Got it. Thank you.
no worries. Awesome. Well, I know we're 2 minutes over here, so if there's no further questions, yeah, thanks very much for joining, everyone. If you do have any other questions, feel free to just reach out to myself directly or to our support website, and we can answer anything else you have from there. But look forward to the next webinar in 2 weeks. So thanks, everyone. Enjoy the rest of the day.